In our previous video, we have seen how to create Apache Beam notebooks through Dataflow Workbench, and we have seen few examples, right? In this video, we will see how to create Apache Beam pipelines and also PCollections, right? Since it's the interactive environment, we'll try to explore each of this concept in detail with examples. Okay, so Apache Beam is a unified programming model for creating batch and stream pipelines. I am highly recommending you to go through this particular documentation, right, which is available in this path or URL, so which will explain each and every concept related to Apache Beam with clean and neat examples. Okay, so in this video I would like to concentrate on much like the complete technical aspects of creating Apache Beam pipeline. Okay, so basically, in order to create Apache Beam pipeline, first step or first thing we'll do is we'll create a driver program, right, which uses classes from Beam SDK, right, software development kit. So Apache Beam SDK available in different programming languages like Python, Java, Go, and there are other programming languages like SQL also. Okay, so driver program defines our pipelines using classes provided by Apache Beam SDK, right? So there are many abstractions available from Apache Beam SDK like PCollection, Beam pipeline, P transformations, IO connectors, right? So driver program essentially uses all these abstractions to define our pipeline. Okay, we'll see them in step by step. Okay, first of all, we'll write a driver program. So that is what we are going to execute. That is where we have our Beam pipeline, right? The first thing is inputs, right? Input means, so we'll try to read data into PCollection from different sources. Source can be an internal source or external source. Internal means we'll try to create PCollection, so the data which is already available in the in memory, right? That is one way, right? Or else we'll try to read data from external sources like GCS, BigQuery. There are other sources available, right? It can be a batch source or stream source, right? This is input. The second thing is transformation. So transformation means, so we'll try to apply series of transformation on top of PCollections. That is our input data. So transformation means we are going to change the form of data, right, from one state to the other state, right? That is called the transformation, right? So we'll try to apply series of transformation based on our requirement. So we'll apply, we also call it as a P transformation. So there are many P transformations available, inbuilt P transformation coming from the Apache Beam SDK. So like map, flat map, group by, co-group by, etc. If you have to define or create your own logic or user defined logic, we'll try to use parallel do, right? So third one is output. Once we have the transform data available, we'll try to write the data into external sources like GCS or BigQuery or Bigtable, etc., right? The final one, so once we have our Beam pipeline defined, we'll have to execute that pipeline in our backend environment. So backend can be anything, any runner, right? So Apache Beam supports many backend runners like Google Cloud Dataflow, right? Apache Spark, Apache Splunk. There are many runners available. It supports many runners. You write the code only once and you can use the runners as per your choice or requirement. So this is the everything is right packed together, and we call it as a driver program. So we'll try to execute that driver program to run our pipeline. Okay, we'll see that example in detail. Okay, so the next thing is, what are the different steps, right, driver program follows, right, to execute our pipeline. First of all, as I already told, we'll create a pipeline object. Okay, so because I already told, Beam SDK is providing abstractions, different abstractions like beam pipeline, P collection, P transformation, right? So the top entity in our pipeline is a pipeline object. Okay, first of all we'll have to create the pipeline object, and we'll have to set the pipeline option to run our pipeline on the backend runner or backend environment like Dataflow or Spark. Okay, this is the first step. Okay, the second step, so we'll have to create the P collection. So just think, P collection is a data in the pipeline, right? We'll have to read data from either from the external source or in memory data, right? We'll create the P collections. Once we have the P collection ready, then we'll apply transformation. Transformation can be a Apache Beam code transformations like filtering, grouping, analyzing, or else user defined transformation using Pardot, right? And then we'll try to write the transform data into external file or external database or external data warehouse like BigQuery. So we can write files to GCS bucket as well. So for that we'll use Apache Beam IO connectors. While reading data also we'll use Apache Beam IO connectors. While writing data also we'll use Apache Beam IO connectors, right? Finally, we'll have to run our pipeline and the back designated or designated pipeline runner. So example, Dataflow, Spark, Flink, etc. right? So this is how our driver program works, right? So in the demo, what we'll see, as I already discussed right in my previous slide, this is the Beam pipelines. These are the different abstractions provided by the Apache Beam SDK, right? So P transform, P collection, right? So we'll read data from the data source, we'll apply transformations on each of this P collection and then write the data into an output. Okay, this is Beam pipeline. In this video, we'll see how to create simple Beam pipelines, right, using different options, and also we'll try to see how to create P collections like in memory, by reading in memory data and also by reading external data. Okay, so we'll see that in detail. Okay, let us quickly move to the demo. Okay, so I have already my Apache Beam notebook created in my earlier demo, in my previous demo. I've already shown the steps to be followed to create this Apache Beam notebook, right? So I will try to provide that video links with this video description. Okay, please go through that. Okay, so it's an Jupyter notebook, right? So hosted on a virtual machine, right? Provided by Vertex AI notebooks. Okay, hosted by Vertex AI notebooks. Okay, and it is coming with pre-installed Apache Beam SDK, right? So you don't have to explicitly install Apache Beam SDK on top of this notebook, right? So just imagine it as a single node execution environment, okay, for us. So in this video, we are not going to run our pipeline on any distributed data processing environments like Dataflow, right? In this video, we will only concentrate on Apache Beam pipeline concepts, right? We'll try to run each piece of code, right? Like creating pipelines, setting up pipeline options, and creating P collections individually. Since it's an interactive runner, we can explore many things, and we'll try to print intermediate results. Okay, and we'll try to understand it in a better manner. Okay, so I've already created a notebook for our demo with all these examples, right? So if you see, this is one notebook, right? Apache Beam notebook. So in the first example, so I'm trying to create a simple pipeline, empty pipeline, right? I don't include any P collection or P transformation. So I just created a empty pipeline. You can see, so we'll have to import Beam, Apache Beam package or module, and then to create pipeline, these are the two ways you can create the pipeline. One way is you can create the pipeline object like this, empty, and then we'll try to run our pipeline. Okay, so this is one way. We'll try to execute this pipeline. Okay, it's an empty pipeline. I'm not trying to do any other tasks as part of it. So other way is we'll try to create pipeline using with class. Okay, this one and this one, the functionality is same, but the syntax is different. Okay, this is also empty pipeline we'll try to create. Okay, so right, in the second case, now we'll have to set the pipeline options, right? So why we need to set the pipeline options, right? Because once you have created your Apache Beam pipeline, you will have to run it, right, in one of the backend environment like Dataflow or Spark in practical scenario. For that, you will have to specify the data runner as well, right? If you have to run it on the Dataflow, you will have to specify it as a Dataflow runner, and also you will have to specify the project where you would like to run. For example, if you have to run this pipeline on Dataflow, so Dataflow is part of, it must be some part of a project, right, one project. You will have to specify that GCP project. And also, for example, if you have to interact with the GCS bucket, right, you will have to specify the GCS bucket path also. You will be setting up all those pipeline options, right, using this particular option available, Beam options, pipeline options, right? So to set pipeline option, there are two ways you can do. Either you can set your pipeline option using command line arguments, so this is also called custom pipeline option, or else you can set the pipeline option programmatically. Okay, so this is an example of command line argument pipeline options, where you will try to pass your options or input argument to command line. So this particular program will read all your input arguments from command line, and it will try to parse those values, and it will pass those values to the Apache Beam pipeline. Okay, I hope you got it, right? You understand it, you understood, right? So the second thing, you can also set the pipeline options programmatically like this, right? So here I'm trying to set the pipeline option. I'm specifying the GCS bucket location, and if I have to run my Apache Beam and Dataflow, I will have to specify the region from where Dataflow has to spin up its worker nodes and run our workload, right? So I'm also providing the staging and temp location, which will be used by our Dataflow while executing this pipeline, right? I think you got it, right? Now let us go to the concept called PCollection, right? Now we have our Beam pipeline object created. Now we'll have to create the PCollection. So as I already discussed, PCollections can be created in two different ways. One way is to, you can create the PCollection by reading in-memory data. In-memory means you are not going to read data from the external sources. For example, see, this is one text defined within the program itself. Using this create method, I am trying to create the PCollection called lines, right? Now my PCollection lines will have all this data. Let me try to run this code, right? You can see now we have created this lines PCollection. I'm by using interactive runner and interactive beam, I'm trying to print that PCollection line by line, right? This is one way, by reading in memory data. The second way, you can create PCollection by using or by reading external data, either from GCS or from BigQuery. Now we'll see these two examples one by one. Now I'm trying to create PCollection called lines by reading data from a GCS bucket location. This is the GCS bucket. Here I have a data. So again I have a text file over here. So this is the same text file I've used as part of my previous demo. It has some epic story over here, Mahabharat. So I'm trying to read that data into this PCollection, right? Now I'll try to print that PCollection. Let me try to execute this. You can see now there are 10 rows printed, right? So this is one of the way, and we can also create PCollection by reading data from our BigQuery. Okay, so in the first step, what I'll do, I'll try to read a BigQuery table right? And I'll try to read the data into a P collection. I'll try to print that P collection. So here my P collection is table row. I'll try to read data from this BigQuery table spec, okay, this one. So it's a BigQuery public data set, okay. So New York is the data set, city bike stations, it's a table. I will try to read entire data from this BigQuery table, okay. So for that you will have to specify temporary location in a GCS bucket for Apache Beam, otherwise it will throw an error, right? Because you'll have to read data from the BigQuery. It look like it will place that temporary data into GCS bucket location. For that you will have to specify. That's where I'm using pipeline option, right? So I'm trying to set my pipeline options programmatically. Here I'm specifying temporary location, GCS bucket location, right? Then I'll pass all these pipeline options here, right, to my Apache Beam pipeline, right? So I hope you're clear about this concept, right? Now let me try to run this program, right, this pipeline. Now it should read data from this BigQuery table and it should print at least top 10 rows or first 10 rows, okay. You can see it has printed 10 rows, right? So it is having everything, all the columns from the table, okay. Now so this is one way. If you have to select only limited columns from a particular table, if you have to execute or read data through some query, what you will do? For that you can use this option. So I have defined this query. This is also reading data from a same table, but I'm just trying to read only 3 columns, not all columns. For that same thing, okay, just commenting out, and here only thing is you will have to pass that query as a input argument to this connector. This is a IO connector which is available from the Beam SDK, read from BigQuery. I'm using standard SQL, right? So let me try to execute this code again. Now it should read only 3 columns, right? So it will print those results once available, okay. See, this is our driver program, as I already discussed, right? So in which we have, right, we'll define a beam pipeline, right? We will create a beam object like this, and we are setting up all the pipeline options, and we are creating PCollections, right, and are running our driver program to execute it, okay, to execute our pipeline, right. You can see top 10 rows displayed. So this is how you can create Apache Beam pipeline using different options, and also PCollections using different options, right. In upcoming videos we'll try to explore Apache Beam core transformation including Parado, right. Okay, thank you very much for your support and watching this video.